So in this video, we want to graph f of x equals 2x squared minus x minus 15 over x squared minus 5x plus 6. We want to find and label all asymptotes, x-intercepts and y-intercepts, and we want to state the domain. So we're going to go through our process for graphing rational functions. So let's begin by rewriting our function here. And we're going to factor the numerator and denominator to make sure that we don't have any common factors. So if we factor the numerator, we have 2x squared minus x minus 15. That factors into 2x plus 5 times x minus 3. And just to verify that, 2x times x gives us the 2x squared. The outers, we're going to have 2x times minus 3, which would be minus 6x. The inners, we have 5 times x, which is plus 5x. Minus 6x plus 5x is minus x. And then 5 times minus 3 is minus 15. In the denominator, this factors into x minus 2 times x minus 3. So x times x is x squared. The outers, we get minus 3x. The inners, we get minus 2x. Minus 3x and minus 2x is minus 5x. And then minus 2 times minus 3 gives us 6. So in this case, we do have a common factor of 3. So that's something that we're going to have to be concerned with. Now, before I do anything else, I'm going to go ahead and state the domain. The domain is going to be anything that causes 0 in the denominator. Well, since we have x minus 2 times x minus 3, if I set that equal to 0, then either x minus 2 equals 0 or x minus 3 equals 0, which means x equals 2 or x equals 3. So 2 or 3 is going to cause 0 in the denominator, so the domain will be all real numbers except 2 and 3. So our domain is going to be x such that x is not 2 and x is not 3. So there's our domain, or if we want to write that in interval notation, x can be anything from negative infinity to 2, union anything between 2 and 3, union anything from 3 to infinity. So now we want to talk about vertical asymptotes. Well, remember, for vertical asymptotes, we can't have any common factors. If we have a common factor, that doesn't really cause a vertical asymptote. That causes a hole. So for step 1, I'm going to reduce. So I'm going to have 2x plus 5 over x minus 2. So this function equals this as long as x is not 3. If x equals 3, we're going to get 0 over 0. We wouldn't get this particular value. So now this doesn't have any other common factors. 2x plus 5 over x minus 2 does not have any other common factors. So we're going to have a vertical asymptote, and that's going to be the vertical line x equals 2. But we're also going to have a hole in this graph, and the hole in this graph is going to occur when x equals 3. And to figure out what the y-coordinate of that hole is, we're going to substitute 3 in this equation. So if I take 2 times 3 plus 5 and divide by 3 minus 2, 2 times 3 is 6 plus 5 is 11, and 3 minus 2 is 1, so that's 11. So we're going to have a hole in the graph at the point 311. So we're going to have a vertical asymptote of x equals 2. We're going to have a hole in the graph at the point 311. 2. Horizontal asymptotes or oblique asymptotes. Well, in this particular case, notice that the degree of the numerator is 2, the degree of the denominator is 2, so they have the same degree. So we're going to have a horizontal asymptote, and that horizontal asymptote is going to be the leading coefficient of the numerator divided by the leading coefficient of the denominator. So the leading coefficient of the numerator is 2, the leading coefficient of the denominator is understood to be 1, and so we get y equals 2. So we have a vertical asymptote of x equals 2, we have a hole at the point 311, and we have a horizontal asymptote of y equals 2. Oblique asymptote, we're not going to have any. So remember, we either have a horizontal or oblique or neither. So in this case, since we have a horizontal asymptote, we don't have an oblique asymptote. So 3, we want to find the x-intercepts. So the way I find the x-intercepts is I set the numerator equal to 0. Now again, because I have a hole at x equals 3, really all I need to do is look at where the 2x plus 5 equals 0, because at 3 I'm not going to have an x-intercept, I have that hole. So if I take 2x plus 5 and set it equal to 0, then 2x equals negative 5, which means x equals negative 5 halves. So I have an x-intercept of negative 5 halves, comma 0. Again, I'm not going to have an x-intercept at 3 because that's where I have a hole. So I just worried about my simplified function setting the numerator equal to 0. 4, we want to find the y-intercept. So to find the y-intercept, I'm going to find f of 0. So that is 2 times 0 squared minus 0 minus 15. And that is over 0 squared minus 5 times 0 plus 6. Well, 2 times 0 squared is 0, minus 0, 0, minus 15 is negative 15. 0 squared 0, minus 5 times 0, 0, plus 6 is 6. So I have negative 15 over 6, which we can reduce. 15 and 6 can both be divided by 3, and so that's going to be negative 5 halves. So we have a y-intercept of 0, negative 5 halves, and negative 5 halves is the same as negative 2.5. So we are ready to graph, and so we'll do that on a separate sheet. So here I have x-axis and a y-axis. So I'm going to begin by drawing my asymptotes. So we have a vertical asymptote we found at x equals 2. So here is my vertical asymptote, x equals 2. We have a horizontal asymptote at y equals 2. So here is my horizontal asymptote, y equals 2. We know that we have an x-intercept at negative 5 halves 0. So here's negative 3, negative 2, negative 1. So negative 5 halves 0 is here. We know we have a y-intercept of 0, negative 5 halves. So here's negative 1, negative 2, negative 3. And that y-intercept is 0, negative 5 halves. So this is the point 0, negative 5 halves. I want to label that. And this point up here was the point negative 5 halves 0. You happen to have the same value on both of those, but that's not necessarily going to be the case. It just happened to be the case here. So I have an idea of what's happening on this side of the graph. This graph is going to be coming here. It's asymptotic. It's going to go through that x-intercept. It's going to come here, go through that y-intercept, and turn and get asymptotic to this vertical line x equals 2, and this way it's getting asymptotic to our line y equals 2. I need to figure out what's going on the right-hand side here, and I also have to remember that I have a hole at the point 311. So here is 3. So here's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I kind of broke my scale a little bit here. So I'm going to have a hole up here at 311. Let me scoot that down a little bit. So I have a hole up here at 311, and that graph is going to be going through that. Okay, I could find some other points, but I have an idea of what's happening. This graph is going to be going here and going on up and getting asymptotic to this line x equals 2. It's going to be coming down through here and curving and getting asymptotic to this line y equals 2. So it wouldn't have that bend in it like I've drawn here, but it's going to keep going up, getting asymptotic to x equals 2. I've got the hole there. It's going down, getting asymptotic to y equals 2. So my graph's going to look like this. If I bring in my calculator, I can enter in our original equation, parentheses, 2x squared minus x minus 15, close the parentheses, divided by, parentheses, x squared minus 5x plus 6. And if I do a zoom 6, I get this graph. If I try to plug in 3, so let's do trace, and if I plug in 3, I don't get a y value because I have a hole there. But I can see that I'm getting asymptotic to the line y equals 2, and I'm getting asymptotic to the line x equals 2. So here is our graph.